Hey everybody, welcome back to Sword Wolf Forge. Today's the big day. You've been hearing me talk about heat treat in pretty much every single one of these 101 videos. And today we're finally getting to it. So what is heat treating? To simplify it, it really is several different phases or steps that we take to molecularly change the properties of this steel. And I'm going to show you a demo of what I'm talking about here in a minute. That being said, this is a necessary step in bladesmithing, and it may be the most important, okay? Because if you mess up with this, you've got a paperweight. That's about it. Now, you need to do heat treating whether you are forging or doing stock removal. And even though this steel is annealed from the factory, you don't know exactly how well it's annealed. You don't know exactly what grain structure there is. And so you want to go through all the steps. You want to do a full anneal again and do every step. You don't want to skip some just because it says it's been annealed. Okay, some people might argue with me on that. That's fine, but how I do it in my shop, I do it every step. The other reason I say that is, especially when you're new, you can get this repetition down and get the system down completely instead of, okay, well, I'll just pick up at step 3. You're not building muscle memory or brain memory that way. Okay, so we want to do it every step, every time. Again, whether you're doing stock removal or forging. Okay. There's 3 ways you can do the heat treat. There might be more, but there's 3 main ways you can do a heat treat. You can do it in a forge, and that's probably how you're going to be doing it at first. Okay, it's not super accurate. I know some people that sit there and say, well, I can do it in a forge just as well. Well, I disagree with that, but more power to them. But when you're first starting out, you're probably going to do it in a forge. The way I do it is with the heat treat oven. It's a lot more exact. You can also place your blade in the oven, program the parameters you want, and walk away from it. The last way of doing it, and I don't have a lot of recommendations on how you go about this, but you can actually, there are companies out there, you can take your blade, send it to them, and have them heat treat it for you. Okay, and I've known some guys that have done that. And if you want to me, one is that's extra money coming out of your pocket. The other thing is you're not learning heat treat. And also there's time. Okay. Heat treating takes a long time, even in the shop. So it would probably take a lot longer. You got to, mail this, wait for them to do the heat treat, and then wait on it to come back. So, and what we're going to do today, we're going to be doing it in a forge. I'm going to show you how to do it in a forge. You're not going to learn that much on my heat treat oven because, again, you're probably not going to have one just yet. Now, the information I'm going to be sharing with you, one is I've made a lot of these mistakes in heat treat over the years. And again, this can be one of the most overwhelming topics or subjects that you can get into. There's so many technical terms, so many this or that, and I'm going to very much simplify it. Now, I've gotten, again, over the years, I've gotten information from different smiths. I've gotten information just by my experimentation, and also by this book by Dr. Lauren Thomas. He's better known as the Knife Steel Nerd. I mean, this is a whole book on just heat treating, everybody. He also has a very good YouTube channel and a very good website that is full of great information. but let my experience, I'm going to simplify it very easy so it's easy to understand for you right now. And Dr. Thomas has a kind of like a saying, and I think it's a great saying. When you're first starting heat treating or knife making, bladesmithing, and you get into heat treat, it's kind of like baking cookies for the first time. If you got a good recipe, you just follow that recipe. You don't need to exactly understand what the baking powder does or soda or the flour or anything like that. You just put in the ingredients as they're spelled out. And if you do that, you're going to make a cookie. You don't have to understand everything else as of yet. But once you get more experience under your belt, you're going to be like an experienced baker. So if you make the cookies and they're a little dry or something like that, you're going to know what ingredient you need to change or move around a little bit to give yourself a better cookie. And once you understand this learning curve of heat treating, you're going to understand more about what does this term mean, or maybe I should bump up this temperature, or maybe I should do this longer. So again, don't let this get overwhelming. What I'm going to do now is I'm going to show you a demonstration over by the vise on, you can actually see why we're doing a heat treat. So let's get over to the vise. So what I've done here is I've got a piece of stock 8670 3/8" thick in this vise. This is from the factory. It's been annealed, but that's it. Okay, it has not had any sort of heat treat whatsoever. And what we're going to do is we're going to demonstrate the difference between raw 8670, and we're going to compare it to a piece of 8670 from the same batch that I have properly heat treated. So I'll show you what the difference is. Snapped right off, bent a little bit, and then it snapped right off, which is to be expected, okay? It's not been heat treated. And it didn't take a lot of effort to do that, okay? So I'm going to show you two different angles of me hitting this. This has been, again, heat treated. Same steel. I'm going to show you a close-up, and then I'm going to zoom out view and show you how much force I'm putting into this steel, okay? So, you can even hear a difference, can't you? Better view of how much effort I'm putting into this. Okay, so that's a demonstration that I give my students. I actually had a client over today and we were discussing a project for him, and I actually showed him this same exact demonstration. But again, these are the exact same steels from the same batch, but look at the difference it makes with the heat treat. That knife, this knife steel is tough, okay? And so now we're going to start the steps on being able to turn this into this. So let's get going. Okay, the first step that we want to take in our heat treating process is a term called normalizing. And not to be confused with some people have another phase called grain refinement. This is a little bit different than that. We will refine our grain as well. And what we mean by grain refinement, let's get into that real quick. So especially when you've forged your blade, all the molecules in that steel can kind of look like this. They're all different shapes, sizes. They're randomly patterned or spread all over the place. And it's not optimal. So when we do a normalization / grain refinement, they're not the same, okay? But within normalization, you do get grain refinement. And what we do is we take all of our molecules and make them uniform, both size, and we get them all lined up real nice. And that's where you get your strength in your blade. So I'm going to show you what you actually, after you watch this video, I'm giving you for free my 5160 heat treat recipe. Okay. And I'll show you where you can get your information, the same information on other steels. But what I want to do in my normalizing stage is I'm going to heat the blade up to 1600 degrees. And you're going to see this term soak quite a bit. 15-minute soak. What that means is I'm going to leave it at 1600 degrees for 15 minutes. But again, just because you're getting my 5160 heat, here's a data sheet on ProCut. And I think when we were talking about steels, I talked to you about data sheets. So you can see here they've got normalizing. Okay, so for ProCut, normalizing would be 1650 in a soak for 10 to 15 minutes, and then you let it air cool. You'll pull it out, put it in a vise or something, let it air cool. So you see there is a little bit of a difference between 5160 and ProCut. So every steel's different. You don't want to just say, you know, I've got one recipe, it works for every single steel. No, it doesn't. So you'll see this. This is the first thing you want to look at. Now you can get this forging. There's forging temperature. We're already past that. But we're on normalizing. So that's what we're going to do next. But we're going to do it at 1600 degrees in 15 minutes. So, and I'm going to show you how to do it in a forge. So I'm going to get the forge heated up. And we're going to do this, everybody. Before we go over to the forge, I kind of want to familiarize just what kind of equipment we're going to be using. I think I went over this before in another previous one-on-one video, but I want to show you again what we're using here in the forge. This is just like a 2x2 piece of square tubing. And we're going to stick that in the forge. And what that's going to do is it's going to distribute the heat a lot more evenly. Because we don't want hot spots. We don't want like a temperature of 1600 here, 1500 here, 1700 here. This will help distribute the heat a lot better. Okay. I've got a little thermometer here with a probe. And what we're going to do is when it's in the forge, we're going to stick this in here so we can see what the temperature is in here. And then we can monitor our gas flow accordingly. So, you know, if it starts getting up to 1650 or something, we'll just turn the gas down a little bit. Again, this is a lot more complicated to do it in a forge than it is a heat treat oven. But this is how you can do it. Another thing we're going to try to use, if this will fit, this is just a fire brick. And I took a grinder to it and ground it down so you can put your knife in there and it'll sit in there evenly. Because you don't want your blade sitting in there like this, flat. This is going to be getting more heat than this side. So we want to try to be as uniform as we possibly can. Okay, so now I can kind of familiarize what is a lot easier to show you here than when it's in the forge. So I'm gonna go ahead and get this all set up, and then I'll show you what we're talking about. Okay, so here's my setup right here. I'll bring you around. So I got and I haven't done this in years, okay? So bear with me a little bit. But we're already about 930 degrees. And unfortunately, my little holder would not fit. But I've got my blade resting up against the wall of that pipe. And so I think it'll be pretty even and good to go. I probably could use a bigger pipe actually. But another reason why we're doing this normalization also, it relaxes the steel, especially after you forged it. It's got a lot of stress on it. And so what normalizing does, it not just refines those grains for us, but it also relaxes the steel. So I'm going to turn this off until we get up to the temperature, and then we'll pick it up once we're at the good temperature, and I'll show you what we're doing. Okay, everybody, we're about 1578 and going up, so we're almost at that temperature. A couple people have asked me, do you put the knife in now, or do you just put the knife in when you start heating everything up? I put it in there when I start heating everything up. I don't think it makes that much of a difference. Now, I think some people might say, well, you're supposed to do it when it's at 1600 degrees. I don't think it makes that much of a difference. Well, what we want to do now is we want to keep an eye on this and try the best we can to keep it at 1600 degrees for our soak time, which was 15 minutes. So I'm not going to be on here all 15 minutes. I just kind of wanted to show you we're almost at our temperature that we want. And then I'll kind of show you what I do to kind of try to keep that as even as possible. Now, that being said, it's not going to kill you if it goes up to 1650 for a little bit. Even my heat treat oven, if I programmed in 1600, it'll get up to 1620 sometimes, and then it'll come back down. So we're at 1600 right now. Voila. So let's start laying off on the gas a little bit. Okay, now I actually took it back down a little bit. So we want to bump it back up just a little bit. And we're at 3:45, so around 4 o'clock, we'll be good to go. A little bit more gas. And this is what the big pain is with this. You got to keep on going back and forth to try to get that temperature as close as you can to your desired temperature. But again, it's doable. So I'm going to put the camera down, get this cycle done, and in 15 minutes we'll come back, and I'm going to actually show you a couple other things. Well, one thing is, you hear about critical temperature, and that's where all the molecules start bouncing around and everything, and you lose the magnetic properties of that steel. And I'll show you when we pull this out. A magnet will not stick to this thing. Some people, if you don't have one of these, thermometers, they'll gauge their temperature by the color of the steel. Well, that's not super exact. Another kind of interesting fact, I've seen some smiths, they'll actually put salt in the forge. Salt will melt at 1475 degrees Fahrenheit. So that will kind of give you a gauge on how hot your forge is. So enough worthless information. I will put the camera down and we'll be back when this sucker is ready to get pulled out. Okay, everybody, we're about ready to take our blade out. The temperature really wasn't that bad. I got everywhere up to 1610 down to about 1593. That's very acceptable. So we're going to pull this out. I'm going to show you that this thing is not magnetic anymore. And we're going to clamp it in a vise and let it air cool. Does not stick at all. It is not magnetic. So I'm going to clamp this in the vise, let it air cool, and we're going to get back to the our workbench, and I'll tell you what our next heat treat step is going to be. Okay, everybody. So now we're ready to move on to our next phase of our heat treat, and this is what we call anneal. And what annealing does is, after the normalization, we've got some good grain refinement and everything, but that blade's a little bit hard. We're letting it air cool to touch. Now what we want to do is put some softness and workability back into it for a couple different reasons. Especially after forging, you want to do an anneal. In our previous video, we drilled the holes in our tang for our handles and everything like that. Well, if you forge that blade, it's going to be too hard. We want to do an anneal so we can soften everything up, relax everything a little bit more. And this helps a little bit with grain refinement, not as much, but I like to do an anneal on all my heat treats. So what we're going to do, and you can see if we go to our data sheet on our ProCut, if you're using ProCut, annealing 1350, you heat it for 30 minutes. Your soak is going to be 30 minutes. Now, this stuff right here is a little bit kind of sketchy. Basically, what we're going to do, in a nutshell, I'm going to heat my steel up to 1300 degrees for 20 minutes. And then what I want to do is I want to let the steel cool very slowly, overnight slowly. So what I like to do is, instead of using my heat treat oven, what I'll do is I'll get it to 1300 in my heat treat oven. I will pull it out after 20 minutes and I will stick it in what's called vermiculite. And this is like a very good insulator. And it lets the blade cool down super slow. And again, I let it sit in there overnight. Other things you can do, you can use sand. I've heard of people using wood ash. I think wood ash would just be kind of messy as all get out. Plus, it would take you forever to collect it. Vermiculite you can get it on Amazon, but you can also get this at nurseries. It's used a lot in horticulture. Not super expensive, and it doesn't wear out. The only thing that I have to watch out for is I have to keep it covered because Susie the shop cat thinks it's her toilet. So what we'll do next then is we're going to move back to the forge. I'm not going to film all this as much because you've already seen me do a normalized stage, but I'm going to go through the same steps again. My target temperature now, though, is 13 minutes, or 1300 degrees, I'm sorry. 20-minute soak. And then I'll show you placing it in vermiculite, and we'll leave it overnight. So this video is actually going to take 2 days to make. So back in a bit. Okay, everybody, so we've been in the forge now for about 20 minutes at roughly 1300 degrees. So in a minute here, I'm going to take it out and place the blade in vermiculite, and we'll let that sit overnight. And I'm going to go ahead and get that set up right now. So here's my vermiculite. And what I like to do is I like to just place the blade on top about half of it. I don't like to push it in there because you can warp. And I'll pour the rest of it on top, sealing it in there. And I'll just leave that overnight. Cover it up, leave it overnight. And so with the magic of video, tomorrow we'll start on our next step, which is quenching. Okay, everybody, it's the next day. It's Sunday here, and we're dealing with that stupid daylight savings time, spring forward. I wish somebody would figure this out. Guess it won't be me, though. But anyway, retrieve the blade out of the vermiculite, let that sit overnight. It's nice and cool now, of course. So now we're getting into the step we're going to be getting into quench, and that's the one pretty much everybody's seen on Forged in Fire and familiar with, and about the only step people really know about, but until now. But this is where we're going to be really putting the life into the blade per se. When you're looking on your data sheet, they sometimes call it austenitizing, and I'll show you that here on the top. And again, this is the Pro Cut data sheet, but I'm just using that as a reference so you know where to look. That means quenching. So for like Pro Cut, I think in another video I covered this, you can actually quench Pro Cut 2 different ways for different properties. That's where you find it on your data sheet. Now for my 5160, I'm going to be at 1525 degrees Fahrenheit for 15-minute soak. And I'm going to be quenching in Parks 50, and I heat that to 120 degrees. Now, being a beginner, Parks 50, and every smith has a different opinion on quenchants, okay? This is how I do it here. I like Parks 50. I use it for almost every steel that I have. It's a manufacturer. It's made for bladesmithing. It's made for quenching. You don't have to worry about it breaking down. It will last pretty much forever, at least so they say. But it's very expensive. But if you're doing knife work like I do, several knives a week, that adds up over time. It's worth the investment because you get consistency. And I think consistency is one of the most important things in doing this successfully across the board with your heat treat, with your quench, everything like that. Now, that being said, though, being new,
The best option you would have for a quenchant right now would be canola oil. Canola oil works pretty good for your first couple quenches. The problem with canola oil is it's not made for bladesmithing and the extreme heats and stuff like that. So it will break down. So what kind of problem you're going to run into is you can't look at the oil and see that it's broken down or it's not having the same properties. You might get 3 good quenches out of it, and then you'll start to notice, like, or you may not, you may not notice that your blades are not as hard or something like that. That's the problem you run into with canola oil. Now, if you want to keep on, if you're going to use it, I would do maybe about 3 quenches and then chuck it and get some new oil, which can add up too. But again, you want consistency, because what's got to again, you know, your first knife might be great and your 10th knife might be terrible. So you need to keep that in mind when you're doing quenchants. How I heat mine up is I got this old camp stove, and you'll see my setup, but I'm kind of showing you the stuff on the side instead of when I'm using it. I've got a big piece of gas pipe that, you know, sealed off, and that's where my quench oil's in. So I put it on top of this, I heat it up, and where did I put it? I've got this remote meat thermometer that I can put this probe in the oil, and I can gauge how warm it is. Now, the reason we want to heat up the oil is it changes the viscosity of the oil. It makes it more, I don't know the best way. It just changes it to where you can get better coverage on the blade, if that makes sense. So I always heat up my oil roughly around 120. It doesn't have to be exact. You're just heating it up, though, to change the viscosity, getting it more fluid, moving and stuff, to get a better quench. Another thing we want to notice is on our 2 other cycles, like when we normalize, we just let it air cool. Anneal, we let it cool at a very slow rate, pretty much overnight. With quench, you are cooling it very quickly. And you are basically telling those molecules in this blade, I want you here now. And what that will produce is, this is where you'll get your hardness in your blade. It'll be super hard, but it'll also be brittle. But we'll have another heat treat cycle after this that will remedy that. But I just kind of wanted to give you a heads up before we do everything. So you've seen me use the forge, how we heat treat over there. I'm not going to go through the whole smeal. I'm just going to turn the camera on when we're about ready to quench. I'll run you through what we're doing and why we're doing it, and we'll get her quenched. Brief time out here for a minute. I forgot to mention something over at the bench when we're talking about quenching. We just annealed that blade, and that blade's nice and soft now. So especially if you've forged your blade, before you quench, now would be the time to drill your holes in your tang. And some smiths will even do an initial bevel grind because the steel's soft. That's really up to you. But you do want to drill those holes in the tang before you quench, okay? Because after you quench, you're going to need some uber carbide blades to get through that steel. And I apologize for kind of back and forth a little bit. And we drilled those pins in the last video just because that steel was already annealed, and I kind of wanted to have this segment all heat treat, not heat treat, okay, now let's go over and drill these holes and everything like that. So I apologize for the confusion, but I wanted to mention that before I quenched. So here's my setup now. You can see I've got my thermometer in the forge, and then I've got this other thermometer for the oil. The oil's heating up. That's my quench tank on the stove. And then we've got the blade in the forge heating up. At the end of the video, I will at least show you briefly how I heat treat now with my oven and such. But we'll let that get heated up to temperature, and then I'll turn it back on, and we can you can see the quench, how we quench. Okay, so we've been heat soaking in there for 15 minutes now. Temperature's bounced a little bit. It had to do some adjustments on there, but we kept it pretty much in good range. I kind of overshot my temperature a little bit with the oil, but that's not going to hurt anything. So we're ready to quench. A couple things you want to keep in mind is get a good grip on that blade. Also, you want this thing coming out of the forge and right into the oil. You don't want to fart around or take your time. You want to get it into the oil as quickly as you can get it. So we're going to go ahead and we're ready to quench. Good grip on her. And you want to move the blade up and down. You want to oscillate it in the oil. And the reason why you're doing that is because if you just leave it in there, it's so hot it'll actually create like an air pocket around the blade, and you will not get a good quench or an even quench. And I usually do this for about at least 10 seconds. And another thing you want to know is, like, especially with Parks 50, it has a very low flash point. You might have seen Forged in Fire or something like that. They dip it, the contestant will dip the blade in the oil, leave it in there for a second, and pull it right back out. That's not a good quench. And it will also ignite the oil. I mean, you'll have a ball of flame up to here. That's a cool factor, but it's not good. You don't want that. Leave it in there. It's not going to hurt anything. And you can check it to see if there's any warpage. It's nice and straight. And so now I'm just going to set this aside. I'm going to put it in a vise. I want it to cool down. Let it air cool. And you don't want to lay it on an anvil or anything like that flat, because what will happen is it will warp. The anvil will act like a heat sink and pull the heat out of one side of the blade quicker than the other. And so it'll be straight right now, but you'll get over there you'll go pick it up in 10 minutes and the thing's warped on you. So don't do that. I like to clamp it in a vise. Let it cool that way. Now, some people, you might have seen some people do a file test on this. I don't do that either. Two different reasons. First reason is there is a lot of decarb. Different steels have different, like there's a layer of decarb on here. 80 CRV is terrible about it. And you might run your file across that thing and you're actually just digging into the decarb. So it's not a really good gauge of did it quench right. In my opinion, I've done enough of these that I know my heat treat recipe. I know my oil. I know this thing's quenched correctly. So if you want to run a file, go ahead, but I don't do it. So I'm just going to go ahead and clamp this in a vise, and then we will get on to our last steps of heat treat. Okay, we let the blade cool down to about room temperature. You can let that cool down for quite some time if you like. If you run into something, that you have to, that takes you away for a while, it's okay to leave that blade the way it is for some time. I prefer, though, to go into tempering, which is our last step, pretty much right after I quench. I mean, I let it cool down, but I like to do everything all at once. I have heard some horror stories with making like pattern welded steel and stuff where they let it cool overnight. They came back out and the billet has pretty much exploded per se, or come apart. I've never had that problem, but when it could be because I elect to temper it pretty much immediately after a quench. So this is going to be our last cycle. It's called tempering, and for my recipe, I go 400 degrees for an hour. I then take it out of the oven, let it cool down to room temperature, and then I do it again. Now, again, everybody's recipe is different. Some people do 2 hours times 2. Some people do one, whatever you feel comfortable with, but I've had pretty good results with 5160 at least for 400 degrees. You also, on your data sheet, can get recommendations on tempering. This is again the Pro Cut, but anywhere between 300 and 400 degrees if you want high hardness and edge retention, and then if you go 450 for high toughness. That's for Pro Cut. With 5160, normally I'd go with 400, but you could go anywhere in a range. Most of my temperings for different steels is between 400 and 350. And what you're doing is, when I said in the quench, we made this really hard. And the reason we're tempering this is to put some flexibility back into the steel. So this is very hard but very brittle right now. So why we are tempering is to make this more usable. We're going to take some of the hardness out of it and put more flex into it and workability into it, because the knife is not going to do us any good if the first time you use it, it snaps or chips. You can get chips on your edge. So we want to put that workability in here. I use a toaster oven out here in the shop, and I'll show you the setup here in a minute. You can do this in your oven in the house. First thing is make sure you're on good terms with your wife. You also want to clean all that oil off, because if you don't, it will smoke up your kitchen, and then you won't be on good terms with your wife. But normally I do it out here in the shop. Now, if I've got a real big knife, because my toaster oven isn't that big, I'll have to do it inside in the big oven. But most of them I do out here in the shop. And you can pick up these toaster ovens. I think I picked this thing up at Goodwill. And I also got a supplementary temperature gauge, because these temperatures can really vary. So I got a supplemental temperature gauge to put inside in the oven, so I can really kind of gauge what the temperature is in there. And I've seen some guys, man, they get some really kind of elite setups for tempering. This has really done me okay. Another thing we want to do, I've made this is a little kind of like jig, and you can put the blade in here. I use this on all my blades when I temper. Several different reasons why. One is you can see that it's straight up and down. So I'm going to get even temperatures on both sides of my blade. If you lay it down and they're flat, one side's going to get more heat than the other side. So this makes sure you got nice even heat on both sides. And the other thing about it is this will keep the blade from warping, because sometimes they will warp on you while you're tempering. But this is just a piece of angle iron, 2 pieces, drilled a hole through it and put some bolts in there. And it's really simple. And I recommend making something like this so you can, when you temper. So I'll get this all tightened down and we'll go over to the oven and I'll show you how I temper, and that'll wrap things up. All right, so we're going to fit this in there. This is my supplemental thermometer to make sure I'm right around 400 degrees, because this isn't 100% exact. And the timer doesn't work on it either, but I've got a clock out here. Go ahead and turn it on. She'll heat up, and in a couple minutes I'll come back. I'm not going to video that, but I want to make sure, I'll check that thermometer in there to make sure I'm right at 400 degrees. And then, like I said over at the table, after about an hour, I'll shut this off, open the door, let it air cool, and then I'll start another cycle. And then you've finished heat treating. You have a fully hardened and workable blade at that point in time. Okay, so I told you I was going to show you a little bit how my setup runs, how I heat treat. This is a heat treat oven. And this is a blade that I'm about ready to quench. So I got all kinds of different recipes I have programmed in here. I've got some normalization cycles. And I'm just going to go and find my 5160. There's 5160 anneal. There it is, 5160 quench. I load it in and I can show you 1525 for 15 minutes. Just like we did in the forge. But all I have to do now is put my blade, and you see I've got one of these made to hold the blade upright. Put the blade in there. Start her up. And pretty much you can walk away from it. It takes a while to heat up though. This will take about an hour to get to temperature. But now I can go and do, work on another blade. I can forge something out. I can do handle scales. I can do whatever I want. So this is one of my favorite pieces of equipment in the shop. It makes life a lot easier, but they can be pricey. But if you're going to be doing this, you're going to really want to get into it, I would highly recommend purchasing a heat treat oven. So there we have it. We've got our heat treat complete. I believe it's the most important phase of knife making. There's a lot of information and it can be very confusing. So I hope that I was able to condense some stuff and simplify it so it was easier to understand for you, because this was really the hardest part of me learning when I first started. I couldn't remember what step went where, what temperatures. I recommend you make a logbook so you can log everything down. But we went through every step. We went through normalization, why we do that, what does it change, anneal, that's your next step, the quench, and the temper, and why we do each step and in that order. Also, again, remember that every steel's different. All those temperatures and
soak times and everything like that can be different for each kind of steel. If you do have any questions, feel free to leave a comment, or you can find me on Facebook at Sword Wolf Forge, or I also got a personal page, Andy Burcham. I also have an Instagram page for Sword Wolf Forge, and you can also reach out to me through www.swfknives.com. That's my website, and there is a way to contact me on there if you have any questions. Our next phase, or our next video in the 101 series, will be grinding. So we'll actually be cleaning everything up. We'll be putting bevels on our knife. So I look forward to that. And I thank you for joining me. I do hope that you got something from this. And do me a favor, like, share, subscribe. It's going to help me grow this thing. I want to make this to be able to reach out to more bladesmiths that are really wanting to learn. So anyway, thanks again for joining, and stay sharp, everybody.